Hello and welcome to the episode 8 of Code Deep Dive. In this episode I will show how type traits work in C++. If you find presented content useful, don't forget to press the like button and subscribe. Let's declare integral constant for type integer and value 3. Integral constant is a base structure for most of the type traits. It's a templated structure that holds past value as a static attribute and declare aliases for the templated type and itself. It additionally defines casting operator that turns each structure object to the template parameter value and callback operator that allows invoking this structure for the same effect. So it's basically holder for the value of specific type that's available at compile time. I will create a variable of value type that is assigned from automatically casted trait structure. I can also access value directly from the trait structure definition. After running this code, we see that trait structure does not contain any attribute itself. In both cases, value of 3 is assigned to the variables. Let's check other traits. I will use is floating point trait with int as a parameter. It's defined as follows. Firstly, there's a removal of const and volatile from the type. There's a use of alias that extracts type from this removal. Usually double underscore in prefix means compiler built-in trait, and this is the case for no compiler. This construct will return per type. Helper is declared for all supported floating types as inheriting structure from true type and for any other as a false type. False type is an alias for bool constant with false value. Bool constant is an alias for integral constant, the definition that we already know that works with bool values. These two will capture either true or false condition result. After running, we see that the value is false as expected, since integer is not a floating type and the resulting value is automatically casted from integral constant structure. Let's deep dive into some more advanced definitions. I will use is scalar v this time. Suffix underscore v is a type of alias for value stored in a scalar trait. Is defined as logical OR between many traits of the past type. We can check each of the conditions. Arithmetic is defined as either an integral or floating type. Integral helper works similarly as is floating helper. After removing const and volatile from type, it's defined as true type for integral types and as a false type otherwise. Enum uses compiler built-in to check type. Bool constant is an alias for integral constant of type bool. Pointer is a true type, but only for pointer type arguments. Null pointer will be only a true type if the past argument is of standard null pointer type. So, OR trait accepts only bool integral constants. OR is declared as type returned by OR function that processes many input traits. Its typical use of substitution failure is not an error that will try to match the types to resolve type definition. There are two declarations to resolve. The first one is defined as a first type trait that simply returns first past type, in this case false type. Whenever this one is evaluated, it's evaluated to false type then. For this trait to be resolved, at least one of the enable if t has to exist. Enable if t accepts bool value that is a cast result from the input traits. Let's deep dive to see how it works. It's a type alias for enable if, and enable if by default has no type for bool parameter. However, if the first parameter is true, the resulting structure exposes a type. If all of our conditional traits are true, only then all enable if t can be evaluated to types, and first t can be triggered. This is the only case when OR statement can be false. If at least one trait cannot be resolved, the whole statement cannot be resolved and the resolution falls into true type. There are many traits declared in type traits header. A lot of them use compiler built-ins like isUnion, class, function, or object. These are aliases for each of the type trait attributes, like values or type. In this video, I showed how type traits are designed in C++. In the next video, I will show how optional is designed in a standard library. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.